Hey everybody, it's Stove Talk with Matt. Please see 2 videos back if you don't know what this is. This is the continuation of the chimney coal stack stove, which went very well. The purpose of this was to, one, really give a torture test to the fire bricks and to add a full 7 inches of a coal bed. The next few minutes of this video will be like in chronological order, me establishing the coal fire. You start with wood, then you slowly add shovel by shovel coal on top of the wood fire. Then once you get over a 10 or 15 minute period, a 3 or 4 inch layer of coal, then you add another 3 or 4 inches, and that's what I did here. And the blue flames are just starting to come up. This is maybe 3 or 4 minutes later. You can see that piece of wood, that last piece of wood is still there in the back right, but all the coal now has caught. Coal produces flame. It catches and it produces a blue and yellow flame. When you have a good coal bed burning like this, you know you can add more on top. The flame is less here because I added another 2 inches of coal. And then again, you get the blue dancers first, then you get more of a yellow flame as all the coal catches. I'm building up the coal bed. Another few minutes, you can see how much higher the flames are, both yellow and blue flames. I have too much air coming in from underneath for this test. I realize I have too much air, but I'm still building the thickness of the coal bed. Another few minutes went by. All the coal is now lit. Probably have a good 5 to 6 inch bed, but all lit. I could add more on top if I wanted to. So chronologically, this is the last video or phase. Maybe 25 minutes later, something like that, 30 minutes later. Maybe more because the bed seems lower. I know I have way too much air coming through. It's over firing. If this was a iron stove in the house, it would be over firing. Too much air, too hot. But it takes a month to know your stove. You know, to back the air down, to know when to add an 8 or 9 inch bed of coal, and then to reduce the air. It takes a month, and this is something I just built in the backyard. For the purposes of this test, I had to err on letting too much air through. But this stack of fire bricks, which is like a chimney stove, the tests are going well. You could load it up with 10, 12 inches of coal, no problem. I think the draft is so aggressive, especially if you have a larger coal like a nut coal. But then you definitely need to back the air off or it will overfire and get out of control. Okay, guys, 3 pictures coming up for the back end discussion. This is the stove. It's basically a chimney. That's all it is. But the coal stove is built into the chimney with fire brick. And you see that stool on the back side? The idea, if anybody incorporated this into a cabin, that stool on the back side there, you can barely see it there, would be, that's where you would insert your iron stove. So it might not be that cold. You may not want to burn coal for 10 days in a row. You have an iron stove right on the other side where that stool is, and you just put a 6-inch stovepipe into the stack. You can also use, just as you saw there, use the bottom of the stack as a coal stove. As long as you, it's kind of a big discussion and it's open for debate. If you could add red brick on top of this fire brick, I'm not sure we'll talk about it here. We'll talk about it some other time. It would be better if you're building a cabin and, a cabin with 1 or 2 rooms or an A-frame cabin, something like that. And this stove, the fire bricks stack up about 5.5, 6 feet or so. So if you had a cabin with a higher ceiling, it would be better to go up 8, 10, 12 feet with the fire brick as high as you could, because those fire brick heat up to 120, 140, 170 degrees, And if you eventually get 450 bricks, then you have 450 little heaters. And eventually, when you go through the roof, then you just use your double wall stovepipe. I wouldn't continue the stack out through the roof. I would do something smaller, double walled stovepipe, etc. But the stack of the chimney acts as the masonry heater. Now, the one last thing I have not done, if anybody's thinking, well, you're losing so much heat, of course, directly, you're building the coal fire directly in the chimney. Say this is positioned in the middle of a cabin. Of course, tons and tons of heat is lost to the outside. The last phase of this test would be to create a baffle system going up, or a semi-baffle system. So you see the stove door there. I like a high firebox for a lot of reasons. A high firebox, you get almost no smoke or no smoke because flames lap up high with a lot of air and a good draft. The flames lapping up 3-4 feet eat up all the smoke. You don't really need secondary air and all this rocket stove tinkerer stuff if you have a high firebox. A lot of the Russian stoves have a high firebox. Everything's lapped up before the gas is in the hot flame, and everything's drawn down to the sides and into the second bell, etc. So you still get very little smoke. So the last test for me here will be to build the stack up to about, say, as high as I can and still reach up and put bricks on top. Maybe I can get it up to 8 feet or so. And then, I put that 2-foot piece of stovepipe on top that's insulated that helps the draw. Not that it needs any help. The draft is ridiculous. The space inside the width is only 2 fire bricks wide for the smoke and the gases and flames to come up. 2 fire bricks, one next to each other. So the idea would be to create baffles where you block the left, block the right, block the left, so at about 3 feet above the door, and again trying to get everything, not to create a baffle too soon when all the flame to lap up and burn up the smoke, you'd block off the front with a fire brick. The way this is constructed, it would be 2 fire bricks kind of coming together and touching, but the space would be 1 fire brick, and then you allow the gases to go up through an open area the size of a fire brick. So you block the front. Then 1.5 feet later, you block the back. Still 1 fire brick opening, but see, like left alternating. So your gases are kind of hitting a mini ceiling every foot or 1.5 feet. And then they have to curve around to get out, hitting a mini ceiling. That might hold, again, the hottest, it was probably, the outdoor temperatures keep the fire brick temperature down on my laser thermometer. 170 degrees was the hottest recording I took on one of these bricks, which is very hot. A lot of times the Russians will take their laser recording of temperature in Celsius over the stove, and you're like, that's not hot. That wouldn't heat anything. It's only, sometimes it's only 120, 150 degrees per brick, sometimes even lower. But they have 600, 700, 800 bricks. So that temperature, even though it's not that hot and you could put your hand on it, it's 600, 700 little heaters. It radiates out and heats the entire house. Each individual brick is not that hot, doesn't glow or anything like that. You can touch it almost at all times. So I'm hoping with the baffle system, block the left, let the gases go out the right. Block the right, let the gases go out the left. Back and forth. It slows everything up. Hoping if you could get an extra 15 degrees per brick, raise it up like that, then this stove would really be, I think, would be a great, easy option for people that are homesteading or in a cabin or off-grid or something like that. And my stoves are always about no smoke and simplicity. Somebody left a comment, all you're really doing is you're just making a stove inside a chimney. Like I didn't know that. Yeah, I know. Well, my stoves are simple. I can build more complicated stoves and put a bunch of horse shit on YouTube that nobody can understand, like everybody else does, and all the welders with the rocket stoves and the welders with the rocket stoves. I want people to be able to see it and say, I can do that very easily myself. The other thing with this, if you're homesteading or off-grid or whatever, sometimes it's hard to get a a 350 pound iron stove or coal stove to your location. I mean, some of the old potbellies do break down into segments, but so that's something about the older stoves do break down. They're easy to transport. Some of them that are 80 to 100 years old, the old coal stoves. But the wood stoves aren't. I mean, it's how do you sometimes I can't get a 300-pound stove out to my cabin or whatever. Here, can you get 30 fire bricks at a time out to your cabin? And then maybe you're ready to build this type of stove like in a year or so as you slowly compile the fire bricks. So how I envision people could use this, again, if you have a cabin, off grid, whatever, and you have a pretty high ceiling, you would put this right smack in the middle of the cabin. A lot of these cabins are open. There isn't like rooms with doors all closed off. It's very open. The floor plan's open, or a loft. Put it right smack in the middle and build the fire brick chimney part goes up at least 8 to 10 feet, as high as possible, with as many fire bricks possible until you start to go through the ceiling or the roof, of course, with your double insulated stovepipe. And the idea would be it can act as a coal stove like I just showed you, or like you see that stool on the other side, you would simply back up a wood stove that vents from the back, or it's actually, I guess, better a wood stove that vents from the top, because you don't want that wood stove venting right into your coal bed. You want it to vent. You want a wood stove that vents or chimneys out the top, and you would go out straight up about 3 feet, and then you'd use one of those 90-degree angles to go into the chimney stack here at about 5 feet up in the air, or maybe just a foot and a half below the first baffle. So if it's unless you're in a real cold state like Maine or where, I mean, you don't need to burn the coal. You just use your wood stove. But then, you get that cold snap or wherever you are, you could build a 10 or 12-inch bed of coal, and if you get your air regulated properly, that then burns over, a long time. You don't have to do anything, 12, 14, 16 hours, depending on how thick your coal bed is. And the idea I mentioned in the other video was, if you were going to do this like inside a cabin, you would need to build. My grate here is just that cheap, like chicken wire mesh stuff from Home Depot. In the gardening section, you would make. I think it would be pretty easy, but I don't know how this. I'm not going to test this. I don't know how this would work via the application of it. You'd make a grate where the coal lays across the grate with rebar. This would be probably best, or pieces of stainless steel or whatever you can get your hands on. And of course, your pieces of grate have to be close enough together so whatever size coal you're using doesn't fall through. You couldn't use pea coal, or it would be medium size or what's called nut coal. And the coal sold at Tractor Supply is nut coal. It's a little larger. It's pretty big. So you would have the rebar would make the grate, maybe, I don't know, maybe you just need about 6 or 7 pieces of rebar across. The in the middle it's just 2 fire bricks wide, the opening. And I can't test this, but I think that when you shake a coal grate, when you use all coal stoves need a grate shaker or shaker grate, and that they're kind of complicated mechanisms in a lot of coal stoves. It's beyond the capability here. But if you had a 7 pieces of rebar going through the stove, where 4 inches are sticking out on each side per each piece of rebar, where you could like I think I talked about, like a foosball table. I think if you just took rebar and you shook each piece of rebar back and forth, again, with it sticking out 4 inches on one side, 4 inches on the other, 7 pieces of rebar to make the grate, I think that would be a decent shaker grate. Not as good as a lot of the coal stoves that have the complicated mechanism, but it's called flossing. It's like you just basically like a coat hanger. You could get in underneath very easily through the opening at the bottom, which is very big, And you'd find a way with metal or bricks to close the opening down when you go to choke your air off. After your whole 8 to 10 inch coal bed lights, you choke your air down. I had too much air for too long. It was basically overfiring. It was a good test for the fire brick. Medium duty fire bricks, you had no problem whatsoever with coal. I guess the medium duty fire bricks, they're not kiln or soft fire bricks that go to 3,000, probably 2,000 or 2,200 degrees on the medium duty fire brick. They're heavier, sandier, and less expensive. People sometimes get confused at this channel. Well, where'd you get all those fire bricks? They're $7-8 each. No, that the soft fire brick, the ones you order online, Amazon, the kiln fire bricks are $7 or $8 each. That you can get fire bricks at any contractor supply that outdoor yard that sells cinder block usually, or any brick yard. They're about $2 to $2.08 or something per fire brick. It's not a kiln fire brick. It's a hard fire brick, not a soft. But it's still relatively soft compared to brick. You can drill through it very easily. So you just that's how you basically be like kebabs, shish kebabs. Kebabs on a grill. Your 7 pieces would go across. You'd shake them the best you could. Then you'd come in with your little piece of coat hanger. You'd floss. You just scrape back and forth the coal bed to get those last little pieces out. So you'd have to do both. I don't think the shaker grate would be great or really that good, but it'd be okay. But you floss underneath. Then, once some people that maintain coal fires for 2 months straight, 3 months straight without them ever going out, you wake up in the morning, your coal bed's down, your 10-inch bed's now down to 2 inches, but it's still burning. And you 7 a.m. you shake the heck out of your grate. Most good coal stove has a big handle. Shake back and forth. And if you have a good shaker grate, you don't need to floss too. After the shake and everything falls through to the ash pan, that's when you add an additional, if you're keeping a coal fire going for 2-3 months straight, that's when you add your additional, 6, 8, 10 inches. Depending on your draft and depending on the type of stove, you might be good then for another day, for another 24 hours. It just depends on your setup, your chimney, your stove. It depends on a lot of things. Some people, then they're good till 8 o'clock at night. They have to add another 6 or 7 inches before going to bed. And then, before you add the 6 or 7 or 10 inches, you do your shaking and your flossing first. Then you add on top. And when you add that much on top, you can go 5 minutes later, you open the door, it looks like it's out. There's nothing going on. It takes a while for all the blue flames to get to the top and for everything to catch. But this is like the best of both worlds, I think, because if the baffles keep more heat in the chimney stove, it needs a little bit of help from as it is now. You lose too much heat just straight up. You're heating the atmosphere. But if this baffle system works, block the left, block the right, block the left, block the right, which I think it will. And if we can get an extra 15 to 20 degrees out of each brick, you've got a very simple chimney you put right in the middle of your cabin. That can be a coal stove for 2 months of the year. You got a little wood stove that connects in on the other side. It just connects into it just like a chimney. And it is a chimney. I mean, chimney systems in U.S. homes are such a mess. They're built incorrectly. They're built wrong. They're too wide. This is all you need. Any wood stove can vent using this stack. A big open fireplace around Christmas time, you throw a bunch of logs in and open gifts. No, it's a different situation. But any wood stove, any stove can vent in a stack like this simply by, a 6-inch hole where you just plug your 6-inch stovepipe into the side about 3, 4, or 5 feet up. So I guess that's it for now, guys. I will report back after I do the test where I add another 2 to 3 feet on top. I'll get a step ladder, and then I add my baffles. And I'm hoping the baffles, if I can get 15 to 20 more degrees per brick, then we really have something here. As of now, it's still viable, but yeah, I mean, you're getting a lot of radiant heat, but you're losing 90% of your heat up, up into the atmosphere. It just doesn't hold enough. Like a Russian stove or a masonry stove pulls the gases up and down and around, and it just heats the bricks because they're pulled all over the place. But again, this is about simplicity, and it's also about having the other the other side is will be a connection for an iron wood stove. Thanks.